Okay. I just want to wait a little bit for everyone to join the meeting. Yeah.
Can you mute yourself in Zoom?
Okay. Thank you very much for telling me. Thank you. Now, in principle, you should be able to hear me through YouTube, yes?
Yeah.
Good, thank you. Still, we are 21, so I don't know. Everyone can join. We were 29 in the Zoom meeting, but only 22 here. Okay, so I will start. Is there any problem with others that they cannot join? It might be your friends can help you to join. May you please talk to me? Is there any problem that some of you cannot join on the YouTube channel? Okay, so let me start. So again, we want to talk about the quadratic equation. Okay, so let me just refresh your memory a little bit. So finally, last time we talked about the ABC formula. So we learned that if I have a quadratic equation of this form, in order to solve this equation, one possible way is to calculate the discriminant which we show by delta, which is defined, and I ask you to try to memorize that. It's b squared minus 4ac. A, B, and C are numbers given to you. You put them into this formula, you get a number. There are three possibilities for this number. One possibility is that the number that you calculate turns out to be negative. If you calculate delta and it turns out to be negative, there are no real solutions for this equation. So you would say no real solutions. This is one possibility. Another possibility is that delta turns out to be 0. If delta turns out to be 0, then you have one single answer for the equation, and that answer has this formula, minus b over 2a. b is exactly the number, the coefficient of x, and a is the coefficient of x squared. And finally, it turns out it might be the case that delta becomes positive. Then you have two roots that you can compactly write both of them into one single formula. And that is minus b, either plus or minus the square root of delta divided by 2a. And this delta is exactly this number that you have already calculated. So this is a crash review of what we had before for a quadratic equation. This formula is called ABC formula in the literature. Okay? To refresh your memory, I start with giving you an example and solve it through this ABC formula. But because in the book, the ABC formula is not presented in the body of the text, it is just mentioned in the exercises. But I believe that ABC formula is more efficient, especially if you have worked with fractions. I want to start talking about PQ formula once for all, so that you can compare these methods together. But of course, you are completely free to choose which one you like the most. Okay. So let me give you an example. Solve the following, the quadratic equation uh, 3x squared plus 5x minus 2 equals to 0. So what I want to teach you, I want to use what is on the board and solve this equation for you, which is of course a very simple task. I hope that every one of you can do that. And then I will teach a little bit about PQ formula, which is in the Swedish curriculum most of the time. And then solve this problem again using the PQ formula. Then you can immediately compare the pros and cons of both of them. And then you can choose whatever you like. Anyway, both of the PQ formula and ABC formula are included in the formula sheet, but I really want you to memorize one of them, of course. By doing a lot of exercises automatically, you will memorize it, but yeah, I think it's better to have it in your memory. Okay, so if I want to solve this problem, what I do, first of all, I calculate delta. Okay, so first of all, I need to recognize what are these numbers. So A, B, and C. By comparing this equation with that equation, I immediately realize that A in this problem is 3. And if you have any questions, please interrupt me. And B is equal to 5. And then you remember C is not 2, it is negative 2. You should also include the sign. And then I calculate delta by writing the formula. It's B squared minus 4AC. And then it becomes equal to 5 to the 2 minus 4 times 3 times minus 2. And the answer becomes 25 plus 24, which is 49. And it is positive. So it contains, it has 2 roots, yes? So it means that this is the third case. I need to use this formula to determine the roots, yes? So if you don't mind, let me write it here to save that space for PQ formula. So here I would write x is equal to minus b plus and minus a square root of delta divided by 2a. So this becomes equal to b, in my case is 5. The formula tells me minus b, so it is minus 5, plus and minus square root of 49 divided by 2 times a. A is 3, yes? And then I continue. So I know the square root of 49. If it's a complete square, I have to write it down to simplify it. But if it is not a complete square, just keep it like that. You are not allowed to approximate the answer. So this becomes minus 5 plus or minus 7. And then 2 times 3 is 6. So from here, I have 2 possibilities, yes? I choose the positive sign. It's minus 5, positive 7 divided by 6, which is 2 over 6, yes? And this is 1 over 3. Another possibility is minus 5 minus 7 divided by 6 is minus 12 divided by 6 is minus 2. So my answers are simply 1/3 and minus 2. So you see, this is as simple as that. But now let me talk a little bit about PQ formula. So in the PQ formula, the way that you see it in the book is this. X squared, instead of B, you have PX, and then you have Q, equal to 0. This is why it's called PQ formula. And then you see that what is the main difference? Can anyone tell me what is the difference, the main difference between this treatment of the quadratic equation and this one? Do you see the main difference between these two strategies? A, B, of course, that's the case. But except for that, those are just minor things. I can call this P, I can call this Q, no matter. But there is a main difference more than that. Yes? Yes. It means that in this case, I haven't forced A to be any particular number. It can be any number that it likes. But in PQ formula, if you want to use the PQ formula, you have to make sure first that this coefficient is equal to 1. So this is why, let me emphasize here by writing a capital 1 here. So this formula only works if x squared is, the coefficient of x squared is 1. Of course, that's not a big deal, because even if this is not the case, I can simply divide first. But the downside is that if you divide, and sometimes these two become fractional numbers, and usually working with fractional numbers is harder. That's the downside, okay? So, but let me just continue this method. Assume that I want to find the PQ formula. That's a good practice for the squaring method. I want to use the squaring method to calculate this, okay? To calculate the roots of this equation. So the first thing, this should be 1. This is already 1. So do you remember I moved the constant term to the right? So this becomes x squared plus px. And then I move it to the right, it becomes minus q. Then you remember that you go to scratch paper, you divide this number by 2. After that, you square it. This becomes p squared divided by 4. This is the number that I have to add to both sides, yes? So this becomes x squared plus px, and then plus p squared divided by 4. On the right-hand side, I will also write p squared divided by 4, and then I have a minus q there. But you know that if you use this trick, the left-hand side becomes a complete square, so I can collect it back into the form of a complete square by taking the square root of the first one, taking the square root of the second one, and then write plus in between, because that's the positive version of that. And then instead of this one in the book, the only thing that they have done here, they have collected back into this form. Memorizing it in this form is a little bit easier. And then minus q, and then you take the square root, but again, this is not clear yet. Is it positive or negative or 0? So it means that exactly I have 3 scenarios going on. Depending on this combination is positive, 0, or negative. So the discriminant in this PQ formula is this expression actually. But now assuming that this is positive, let me take the square root. I want to find the formula. So x plus p over 2 becomes the square root of this expression. But I need to remember to put plus and minus. And then finally, I move this minus p over 2 to the right. It becomes negative p over 2. And then I would write the formula here for you. So this is the PQ formula. Okay? So, but this is important. Of course, this formula seems a little bit simpler than this formula. The reason is clear because this number is 1, okay? And if I choose 1, it seems that, so this is the same formula, by the way. If you want, you can use this trick. Okay, I will come back to it. If you put a equal to 1, then your delta becomes b squared minus 4a, and this formula, let us see what happens to this formula. If I put a equal to 1 in ABC formula, then this becomes x equals to minus b plus and minus square root of b squared minus 4c only, because a is 1, and then divided by 2 times a. So that is PQ formula, by the way. How? If I divide this by that, it becomes minus b over 2 plus or minus. Instead of 2, I can write, let me clean this, we don't need this, I want to keep only this. So here, instead of this, I can write it as a square root of b squared minus 4c divided by 2. But instead of this 2, I write square root of 4. Okay? And then I write it as minus b over 2 plus or minus a square root of, I can write b squared minus 4c divided by 4. I have 2 square roots. Square root of something divided by square root of another number. I can write a complete square. I can write a bigger square root and I divide them. But then again, I can separate them. B squared over 4 and then minus 4c divided by 4. And finally, you get this. Minus b over 2 plus or minus, instead of b over 4 to power 2, you write this, minus c. So you see, this is exactly the same thing, the same formula. If I choose a equal to 1, if I choose b equal to p, then this becomes minus p over 2, which is this one, and then this becomes p over 2, minus, instead of c, if I put q, that becomes exactly the same formula. So I mean that nothing strange is going on. But I prefer to do it in this way because it was much simpler, and then it was a review for the important method of completing the square, yes? Anyway, that is your PQ formula. Okay, now let us go back and solve the same problem here, which I got these two answers. Now this time using the PQ formula. Okay, so what I do, I would write 3x squared plus 5x minus 2 equals to 0. If I decide to use PQ formula, I have to respect the rules. So I have to make this one equal to 1 first. This is 3. So I have to divide everything by 3 and then start using PQ formula. So if I divide this by 3, of course, it simply becomes x squared. But you see, this number, which is an integer, working with an integer was easier, now turns into a fraction. And that fraction is a complete fraction, so you cannot write it in decimal points because that would be an approximation then. And then the next term is also a fraction. So if you want to use this for problem, using the PQ formula, it is a have to. You have to make it 1 first. And then you need to compare this with this one and then read P and Q. So P in this problem is 5 over 3 and Q in this problem is minus 2/3. Okay? And then I can go and use this formula from the formula sheet and then plug the numbers in. So X becomes equal to, I have minus P here. So I have minus P is 5 over 3. I have to divide it by 2 because it's P over 2. And then plus or minus square root of the same situation, P divided by 2, and then square it, minus Q. This is the correct way of writing the PQ formula. Okay, then what happens? It becomes, how should you calculate this? Do you remember? This is why I'm saying this is working with fractions now. You put a 1 here, you multiply these two numbers and put it in the numerator, multiply these two numbers and put it in the denominator. So it's 5 over 6, I have a negative sign here. And then plus and minus. If you want to use this, you don't need to recalculate this because you already calculated that number here. It is 5 over 6. Here you just need to square it, so don't do the calculation twice, okay? If I square it, it becomes 25 over 36, and then I have minus minus is plus 2/3, okay? So you see that the only downside is to work with fractions, that's it. But of course, everything is, again, correct. So then I will continue. I have to take the common denominator, so this is 36. And then if I want to make the denominator of this one 36, I have to multiply by 12, so it becomes 36. The numerator becomes 24. And then little by little, you see that the same numbers are appearing, yes? So it's minus 5 over 6, and then plus and minus a square root of, the denominators are the same, so 36, and then I add these two numbers. When I add them, it becomes 49, and fortunately, this is a complete square. Square root of 49 is 7, square root of 36 is 6. So then what happens is that x becomes equal to, so let me write it. This becomes equal to minus 5 over 6, and then plus or minus 7 over 6. Again, I have two options. I have two possibilities, yes? Either I add them or subtract them. So x becomes equal to minus 5 over 6 plus 7 over 6. It becomes 2 over 6, which is 1/3. And then so one answer is 1 over 3. And that is exactly the answer that we got here. And the other answer is minus 5 over 6 minus 7 over 6. So it is minus 12 over 6. And then it becomes minus 2. So the other answer is minus 2. Hopefully you can see everything there. Yes. And then you see that that's the same answer. So the solution is this solution. Both of them are completely acceptable. I'm not saying that something is wrong with that formula. But maybe I myself prefer ABC formula all the time. In ABC formula, I don't need to be worried about if this coefficient is equal to 1 or not. But if you are determined to use PQ formula, don't forget about making this coefficient is equal to 1. Might be, if the coefficient is equal to 1 already, this method is more efficient. But for me, I don't want to memorize two different formulas. So this is why I use this method all the time. So in my solutions, I always, in the board, when I am presenting my solutions on the board in the class, I am using ABC formula. But if you don't like it, you can just, when you are solving problems, you can use PQ formula. Okay, so I just try to present one single example with two different methods. Then that is up to you to decide which formula you want to use. Okay, putting this aside, I want to give you some exercises today. Let us do it together, okay? Any questions so far? Good. So let me clean. And I don't need to write the formulas, I think. So let me write the formula on top and then give you some examples. So this is the example that we want to talk about today. Different parts for solving quadratic equations, or an equation which is not in the standard form, but it can be reduced to a standard form, okay? Solve the following equations. So number one, so 3x squared is equal to 4x minus 1. Okay, so here I want to solve this one for you. How should I know what to do? Immediately, because I see second power is in my equation, and there is no way to get rid of that second degree term, it means that this is a quadratic equation. Whenever it is a quadratic equation, this is the main difference between a quadratic equation and a first degree equation. In the first degree equation, if you remember, I moved the x parts to the left and the constant parts to the right. Okay? But as soon as I recognize this is not a first degree equation, it is a second degree equation, there is no point to split the x parts to the left and the right parts to the right. Every now and then I see some people doing this. So 3x squared, they just move 4x to the left and then equals to 1. And of course, they can somehow factor x out. This is 3x minus 4 equals to 1. I want you to understand that this is not a good method because the product of two numbers is equal to 1. It doesn't tell you anything about these numbers. Yes? If it was 0, yes, you were right. Then I can say either this one is 0 or that one is 0. But when it is 1 or any other number except for 0, I cannot say anything about these two. They can be very different numbers whose product is equal to 1. For example, 2 and 1 over 2, 3 and 1 over 3. Square root of 2 and 1 over square root of 2. The product of all of them is equal to 1. So which one of them is actually correct? Okay, so this is one possible mistake. Don't do it. When you realize that that's a quadratic equation, everything has to be moved to the left or to the right hand side. So if I see this problem, I realize that this is a quadratic equation. The first step I do, I organize it in a way that I make a standard form. I move 4x to the left, it is positive, now it becomes negative. I move minus 1 to the left, it is negative, now it becomes positive. Nothing is left on the right-hand side at 0. And then immediately, you either use PQ formula or ABC formula, or even if you like, even though I don't recommend, if you are not forced to, you can use the squaring, the completing the square method. Even if you solve that one, that's also correct. But whenever I am not forced to choose any method, and if all these terms are there, I definitely immediately use ABC formula. So then what I do, so I would say that don't write too many, okay? So delta is b squared minus 4ac. Even you don't need to write it. I'm just writing it so that you have the opportunity to memorize. So b squared minus 4ac. b squared is 16 minus 4 times this times that. If you are not very quick in calculation, be patient and write every detail, because I have seen many students make a negative sign mistake and then they get a very bad numbers. Okay, so I would say minus 4 times this and that is just 12. If you have any questions, please let me know. And 16 minus 12 is 4. I immediately realize 4 is positive, so I have 2 roots. And I have this in my memory or in the formula sheet, I use it. Again, you don't need to write a formula for it. So minus b is minus 4 is positive 4. Plus or minus the square root of delta. Delta is 4. And then I have 2 times a. A is 3. 2 times a is 6. And then I continue 4 plus or minus. If this number is not a complete square, you can more or less leave it. But if it's a complete square, you have to continue. So square root of 4 is 2, 6. And then I have 2 cases. Either 4 plus 2 divided by 6, which is 1. So one answer is x equal to 1. And the other answer is 4 minus 2 divided by 6. It's 2 over 6. So it is 1/3, yes? So as simple as that. Okay. Now, Okay, so now let me give you another example. So number 2, let me choose the coefficients a little bit more involved in this case. So number 2, let me write this equation for you. Square root of 2x squared plus square root of 2 is equal to 2 square root of 3 times x. Okay, so here I want to solve this equation. Again, how should I think? I know that this is a solving equation, so it means that I need to find x. Immediately I realize that there is a quadratic term involved, and I cannot get rid of this quadratic term, so it means that this is indeed a real quadratic equation. So what I need to do, I need to move everything to the left and write it in a standard form. So for example, if I take this one to the left in this form, it's very important to write it in an organized way. Of course, this is not wrong, but if I ask you what is A, what is B, and what is C, don't get confused. This is of course A, but if you say this is B, that is wrong because this is the constant term. So write it in a standard form means write it with x squared first, then x, then the constant term, yes? So I move it to the left and write it in the middle. So this becomes the square root of x2, x squared, minus 2 square root of 3 times x, and then I have a square root of 2. On the right-hand side, I have 0. So let me be more careful here. So if I ask you what is A, you would say my A is the square root of 2. What is B? It's negative 2 square root of 3. And what is C is positive square root of 2. Okay? Okay, so I calculate delta first. Delta is b squared minus 4ac. So you need to be patient, okay? So what is b squared? Just be patient and write it. Of course, if you can do it very fast, that's okay, but you don't need to do it very fast. So instead of b, I put minus 2 square root of 3, and then I have squared it. And then I have minus 4 times a, which is the square root of 2, times c, which is again square root of 2. Okay, so let us calculate this. If I want to calculate this, this is a product, so hopefully you remember. If I have a times b, and I want to raise it to any power, I can do it in this way. I can write a to the n, b to the n, and then multiply them. So that is one of the power rules, yes? So here, I can raise it to power 2. It becomes minus 2 to power 2, which is positive 4. The square root of 3 to power 2 is 3. And then I am supposed to multiply. Here, I have minus 4. Square root of 2 times the square root of 2 is a square root of 4, yes? 2 times 2 is 4. I can continue again. 4 times 3 is 12. And the square root of 4 is 2. 2 times 4 is 8. So it becomes minus 8. And then the difference finally is 4, and 4 is positive. So it means that my delta is a positive number, and I can calculate the roots. There are 2 roots, yes? And then what is the formula? It's minus b plus or minus the square root of delta divided by 2 times a. And then I go minus b. This is my b. It includes a negative sign. The formula itself also has a negative sign. So this negative sign will cancel the negative sign from here. It becomes 2 square root of 3 plus or minus square root of delta, but my delta is 4. And then divided by 2 times a. A is the square root of 2. I multiply it by 2. It becomes 2 square root of 2. Okay. you see still this is possible to simplify. You see that this might be, for example, a C-level question, yes? And then it means that I want you to show me that you know how to simplify things as much as possible. So square root of 4 is 2. So this becomes 2 square root of 3 plus or minus 2 divided by 2 square root of 2. Okay, now my question for you. Do you think that I can continue and simplify things a little bit more, or is it the end of the story? For example, can I simplify this 2 with that 2? Or can I simplify this 2 with that 2? So you need to remember a little bit about what I told you when I was teaching rational. Yes?
I don't think you can.
Yes, in this form I cannot, because, of course, if I ask you, is this a factor of the denominator, you would say yes, because it has been multiplied. Is it a factor of the numerator in this form? No, it's just a factor of this term. But is there any way out of it to make these 2 to be the factor of the whole numerator? Do you remember we learned about this stuff? Of course, with X and Y and letters, but here we have numbers. If I ask you, if I give you 2x plus 2, can you factorize it? Can you factorize it for me? Hello, hopefully you are studying.
Is it 2 times? And 2 bracket x plus 1.
Yes. So that's the same story here. I have, instead of x, I have a square root of 3. Then I have 2. Can I factor something out here as well? The answer is yes. Again, I can factor a 2 out. Yes, is that understandable? I want you to understand these 2 problems are exactly the same. Here I have x, here I have square root of 3. But I am doing exactly the same thing. Okay, so it's possible to factor it out. But the point is that this one is sometimes positive, sometimes negative. It doesn't matter. If this is negative, when I factor out, what is left is negative. So it means that now I can factor the 2 out. It becomes a square root of 3, either plus or minus, depending on this sign, 1. And then I have 2 square root of 2. But then this 2 is now a factor. It has been multiplied by this. So it's a factor of the whole numerator, and this is a factor of the denominator. So this means that these 2 can be simplified, and then I have a square root of 3 plus or minus 1 divided by a square root of 2. If you stop here, that's okay with me. But if you stop here, that's not that okay. You will lose some points because this is simpler than that. If you don't do this, it means that you don't respect simplifications. Even though I myself will not stop here, because I don't know, usually people in mathematics don't write square third signs in the denominator. They want to get rid of that. That is optional. I just want to discuss it here, but you don't need to do it in the exam. The final point for stopping for this question in the exam is here, okay? And if I ask you, so let me write it here. So answer would be 2 answers, yes? One of them is square root of 3 plus 1 divided by square root of 2. This is one answer. The other answer is this. If you write it in that compact form, that is also acceptable for me, because here these are no longer complete squares, so I cannot simplify them more than that, okay? Either you write it as a compact form or you write them separately. It doesn't matter. But you have to keep the exact form. But I myself prefer, let me teach you some trick. This is optional, okay? Usually, when we have a fraction whose denominator contains a third sign, this the radical sign, this third sign, usually people in mathematics try to get rid of that one Of course, you cannot get rid of all the surds, but what we do, we write an expression equal to this so that there is no surd sign left in the denominator. Okay, so what we do, for example, let me pick one of them. This one. So let me write something. I put equality, so you expect that I write something in front which is equal to this, yes? I do it in this way. First of all, tell me, do you understand that this equality is legitimate here? Do you agree that these and that are the same numbers?
Yes.
Why? Because a square root of 2 divided by square root of 2 is a fancy way of writing 1. Square root of 2 divided by square root of 2 is 1. And I know that if I multiply my number by 1, it remains the same. So there is no difference between this and this. But what is the benefit behind that? Because what will happen, my goal was to get rid of surd sign in the denominator, and this will help me to do that. Why? Because now I have a fraction, another fraction multiplied. I multiply the numerators, so it becomes the square root of 3 plus 1, multiplied by square root of 2. The denominator is multiplied, it becomes the square root of 4. And then I multiply square root of 2 inside. Square root of 2 times square root of 3 is the square root of 6. Square root of 2 times 1 is just simply square root of 2. And then square root of 4 is 2. So you see, you might happen that you solve an equation from a book, you get this answer, but when you go to the faucet has written this answer. You might think that you have solved the problem wrongly, which is not the case, but you need to understand. So this is why I'm teaching you this, because sometimes if you are studying some other books, you solve the problem, you want to check your answer, you see that in the faucet this answer is given, but you see that you got this answer, you might think that you have done it wrong, which is not the case, because indeed these two numbers are equal. So for me, I don't know, this looks nicer than this one. It's more symmetric for my eyes, I don't know. That's up to you. But anyway, you need to learn this sometimes these tricks. That was completely optional for me. So if you stop here, that's completely okay. Okay? But I want you to learn. The people who likes to know more math, it's better to understand what's going on. Okay, so this is one problem. And then another problem I want to mention here is that I give you a problem which has fractions involved from the beginning. And of course, do you remember what we learned in Math 1C? We know the trick. I told you this is my famous sentence, more you can call it a code, yes, above by convention. That is, I hate fractions, yes. So when I hate fractions, I try to get rid of fractions as soon as possible. So if I give you this equation, x squared minus x over 6, and then equals to 7 over 6. If I ask you to solve this, of course this is possible to work with fractions all the time until the very end. Yes? But I told you that I always don't like working with fractions because that's a little bit time consuming. Do you remember what to do? The first statement is to get rid of fractions. How can I get rid of fractions? Exactly the same way that we did.
Everything by 6.
Exactly, thank you. We multiply everything by 6, so you save my breath, okay? So I multiply everything by 6. If I multiply this by 6, it becomes 6x squared. If I multiply it by 6, don't multiply it in the numerator, because the 6 that you are multiplying will kill the 6. So nothing will left. Nothing here means 1. So this becomes minus x. And then when I multiply 6 here, it becomes 7. Of course, if you start working with fractions, continue. So you might say that, okay, I move it to the left. By the way, even if you do it, I want you to understand. So can you tell me, if you want to do it in this way, can you tell me what is A in this problem, what is B in this problem, and what is C for this one? If you don't want to get rid of fractions, which I don't recommend. So what is A in this problem?
A is 1.
What is B?
B is 1/6.
Not 1/6, minus 1/6. Thank you. That's very good to understand. Why? Because minus x/6 is another name for minus 1/6 times x. So it's minus 1/6, and finally it's clear that C is minus 7. And I hope that you agree with me that if you want to write delta for these numbers, it is possible, of course, but then you need to work with fractions all the time. But if you manage to do that, definitely you will get the correct answer. But here, I say that, okay, instead of working with fractions, I multiply everything by 6 to get rid of fractions. Why? Based on what I can do this? Because I am saying that if you want to make this one equal to this, it is sufficient that I make 6 times of this equal to 6 times of this. If 6 times of A is equal to 6 times of B, of course it is clear that A and B are also equal. So there is no difference mathematically between this statement and this statement. If this is true, this is true, and if this is true, this is true. So they are equivalent. So this is the philosophy behind multiplying both sides by a number. So if I ask you, is this equation the same equation as here? The answer is no. If this equation is equivalent to this equation, the answer is yes. Equivalent equations are equations so that the answers are the same, even though the forms are not identical. Okay, and then I will solve the problem. So I will not explain it, so let me just do it quickly. I realize that's a quadratic equation. I move everything to the left. I write the formula for delta. It's b squared minus 4ac. And then what I do is that minus 1 to the 2 is 1 minus 4 times 6 times 7. Oh, sorry, times minus 7. Because C is 7. And so what happens here? How much is that? So 1 is 1. So 4 times 6 is 24. It's 168. But minus is positive. But then when I add them, it becomes 169, which is positive. And then I start solving this equation by writing the formula. So this becomes minus b. Minus b is 1, because b is minus 1 here. Yes, everyone understands. If not, please interrupt. This b is minus 1, so minus b becomes positive 1. And then plus or minus a square root of 169, and then divided by 2 times a. A is 6. When I multiply it by 2, it becomes 12. And these numbers are famous, but you can use your calculator. This is important. If this is completely square, you have to write the answer. Otherwise, leave it like that. Square root of 169 is 13. So this becomes plus or minus 13 divided by 12. So one of you have forgotten to mute the microphone. Okay, so what happens now here? X becomes equal to 1 plus 13 is 14 divided by 12, but don't leave it like that, because 14 over 12 can be simplified. I actually pay a lot of attention to these things in the exam. So it's 7 over 6, and you have to keep it in this exact form. And then I have another one, which is 1 minus 13, which is minus 12 divided by 12, and the answer is minus 1. So if you want a little bit of challenge working with numbers, you can start solving this without multiplying by 6. At the end of the day, you should be able to get these two answers back. So don't forget about getting rid of fractions. It saves you a lot of calculations. Okay, I want to give you one problem. Even though that's a live stream, it is a little bit odd if I wait for that, but that's the meaning of live stream. Okay, so I will give you a question, and I wait. I don't know, should I wait for 5 minutes or what? So let me solve it myself, because I want to cover another part that was not the lesson. It is in the exercises, but it is an important exercise. I want to bring it up to discuss it with you and tell to you that if you are interested in solving harder problems, you need to know this problem by heart as well. Okay, so let me solve this problem myself. Finally, this problem, I want to bring it up. So this is number 4. I want you to solve this equation. Okay. So this is a little bit more complex equation, yes? It's not clear that if it is quadratic, of course we have some hunch about it, because I have a power of 2, it seems to be a quadratic equation, but might be the coefficient of x squared on the left and the right are in a way that they cancel each other out. We don't know. So because of this one, most of the time, of course, it turns out to be a quadratic equation, but if you're lucky, these can be canceled. So this equation is given to you and you want to solve. Of course, it's far away from being in the standard form. So this problem is 2 birds with 1 stone, yes? If you want to solve it, actually I am testing your knowledge about how are you able to multiply polynomials? Are you able to use the squaring pattern? And then, of course, can you solve a quadratic equation? So probably 3 birds with 1 stone, yes? So if I want to solve this, I will try to simplify it. So I will multiply this polynomial, so it becomes 5x squared. 5x times minus 5 is minus 25x. Minus 3 times x is minus 3x. Minus 3 times minus 5 is positive 50. On the right-hand side, even though I can write it 2 times and multiply it, but I really don't need to do because I know the squaring pattern. So what is the squaring pattern? It tells me square the first term, which becomes 4x squared, 2 times the first one times the second one. 2 times the first one is 4x. 4x times 5 is 20x. And then the second one to the power of 2 is 25. These 3 terms are the expansion of this, but I have a positive 90 at the end. Okay? So first I have to expand. After that, simplification. So 5x squared is alone on the left-hand side. Minus 25x and minus 3x are similar terms, so it becomes minus 28x, and then I have plus 15. On the right-hand side, can I simplify more? With numbers, yes. So let me just copy and paste the first 2. 25 added to that is 115. But then you immediately realize that I cannot get rid of the quadratic terms. If it was for some reason 5x squared, then these 5x squared and that 5x squared are canceled. It becomes a first-degree equation. Then I move the x parts to the left and the constant numbers to the right. This will change my strategy. But now that I immediately realize that there is no way to get rid of the quadratic term, it means that everything should be moved to the left-hand side. So it becomes 5x squared minus 28x plus 15 minus 4x squared minus 20x minus 115 is equal to 0. Simplification, 5x squared and 4x squared negative, it becomes 1x squared. Minus 28 and minus 20 is minus 48. 15 and 100, minus 115 is minus 100, is equal to 0. Okay? So I have to start working with this equation. And of course, you have your calculator, so you don't need to be worried about the big numbers involved here. Okay, so I would write my delta. So delta is b squared minus 4ac, but this is my b. Let me emphasize here. So my a is 1 here, okay? So here I have, this is my b, and this is my c. So b squared is minus 48 to power 2, yes? And then minus 4 times a is 1, c is minus 100. Okay, so now I have to calculate this one. So I multiply 48 by 48. By the way, let me use some tricks. If I want to write 48, of course I can multiply 48 by 48, but might be this is also easy. 40 plus 8 to power 2, yes? And then I can use a squaring pattern. This one to power 2 is simply 1600. 2 times the first one times the second one is 640, and then finally I have 64. Yes? So how much is that? Is 2,000, yes, 284. Can you check this with your calculator? I have done right. This is 2,200, that's correct. And then, no, this is 44. No, I'm making mistakes. Okay, so this is probably 2,200.
I got 2,304.
Yes, that's correct. 2,304, yes, because I was mistaken. This is 600. I added to this, it is 2,200, and then I am left with 64 and 40, which is 104. Yes, thank you. Okay, so what happens here? This becomes 2,304, and then minus 4 times minus 100, it becomes positive 400. And then if I add them, it becomes 2,704. And it is positive. Can you please square this one with your calculator to see if there's a complete square out of it? Yes? 52. Okay, good. So let us continue. X becomes equal to, I would write minus b plus or minus the square root of delta divided by 2a. So it is minus b is 48 plus or minus the square root of that number, 2 times a. So this is 52, as you said. And then I have two answers, yes? So x is 48 plus 52 divided by 2, which is how much? Is 100 divided by 2, which is 50. So one answer to this problem is 50. And the other answer is 48 minus 52 divided by 2, which is minus 4 divided by 2, which is minus 2. So the other answer here is minus 2. Okay, any questions so far? So sometimes you have to simplify and then start solving, and you shouldn't be scared from the numbers because you have your calculator available. But that is important to see that if that number is a complete square, don't leave it like this. If that's not a complete square, you can leave it like that, and it's better to do this because that would be a plus. Yes, any questions? Any questions? No? Okay, I hope that you understand what's going on. And then there is something that I want to bring it up that's also very important. It is one of the exercises in the book. I want to talk a little bit about that. and then I will tell you that it is better to have it in your memory somewhere. Okay, so let me clean this. I hope that you don't need to this because you can watch the video later. Okay, so let me clean this. And there are two formulas for finding the sum and the product of the roots of a quadratic equation. Okay? You might say that, okay, there is no need for that. Of course, in principle, you are right. There is no need for knowing a definite formula for the sum and the product of the roots of a quadratic equation, because you might say that, okay, I solved the equation in the way that I learned that. And if you ask me find the sum of the roots, I add them and give you the number. If you ask me what is the product of those numbers, I multiply them and I give you the answer. So I don't need any further knowledge related to that. And you are completely right. But sometimes the numbers looks a little bit contains square roots and things like that, and then working with the square roots could be quite complicated. For example, assume that I give you this equation, 3x minus 10 equals to 0. Okay? And I ask you, I tell you that, okay, x1 is one root, x2 is another root. Assume that x1 and x2 are the roots after that long process of solving. And then I am asking, I am not interested in these two individually. I am asking this question. What is x1 plus x2? What is x1 multiplied by x2? Of course, you can find the roots and then give me the answer. Of course, this is possible. Let us just do it here, okay? If I want to solve this problem, I calculate delta. So delta is what? Is b squared minus 4ac. And then if I plug these numbers, it becomes negative 3 to power 2, which is 9, minus 4 times 1 times this is positive 40. Minus times minus is positive. It's 49, so I have two roots. Actually, that is not a good example. So I don't want, because if this is 49, then it is very simple. So let me change it to 11. Yes, because this is a nice. Whenever this becomes complete square, because that square root sign will be cancelled, that's not a big deal. But let us work with minus 11. And if I multiply minus 11, then it becomes 44. And then this is not any longer a complete square. It becomes 53. But again, it is positive. So I am on the safe side. I have two roots. What are those roots? One of them, so both of them, let me write one formula. So it is minus b plus or minus the square root of delta divided by 2a. So minus b is 3 plus or minus the square root of 53 divided by 2 times a. But because if you use your calculator, this is not a complete square, so you have to keep it in this form. So I have two roots. Which one is x1, which one is x2? It doesn't matter. I don't know which one is x1 and which one is x2. And you see that these questions are symmetric. Yes? Because if it doesn't matter if I change x1 and x2, it becomes x2 plus x1, which is the same thing, and it becomes x2 multiplied by x1. For example, I cannot ask you this. I cannot ask you to calculate this. Then you would say which one I am supposed to take x1, which one I am supposed to take x2 as x2, because this matters, yes? It matters which one is x2, which one is x1, but here it doesn't matter because I'm adding them. Here I'm multiplying. Okay, so whatever you want to choose, you choose x1 to be one of them. Let us take the positive one. And you choose x2, the negative one. Now I am asking you this question. What is x1 plus x2? Of course, it is easy. You just write them down and add them. But when I add them, the denominators are the same, so I have to add the numerators. So, but the good point, what is happening is this bad part is going away because this appears here with positive sign, this appears here with negative sign. So when I add them, this one and that one are gone, and 3 plus 3 becomes 6. And 6 divided by 2 is simply 3. So even if the number involves the roots involve square roots, answering x1 plus x2 is super easy, yes? Because that part will be cancelled. And also something happens for multiplication, a little bit more involved, but that is also possible. So I multiply x1 by x2. So what I do, I write 3 plus the square root of 53 divided by 2, and I multiply it by 3 minus the square root of 53 divided by 2. Now I want to see how many of you study your lessons. I have a fraction, I want to multiply it by another fraction. The simple one I do myself, 2 times 2 is 4. The hard part, I want you to do it for me. How do you want to do the numerator for me? I want to multiply the numerators. Any idea? Of course, it is not hard. You can start multiplying term by term, yes? You can say, so this is what I want you to explain. Pardon? May you repeat it, please?
If you multiply the square roots, it will be -53.
Yes. So what the whole thing is -53, you mean? No, if you mean the whole...
No, because there's a 3, but I mean the square roots would...
No, okay, but so I mean that I want you to give me the answer in its entirety, okay? So, of course, one way to deal with is to use polynomial multiplication. Do you remember? If I ask you multiply x plus y by z plus t, it's hard. It's not hard for you. You multiply this here, multiply this there, and continue. You can also do the same thing. You can multiply 3 by 3, multiply this by that, and then multiply this by that, and multiply by that by that. But there is a much better way to do that. What this pattern is. So let me write it next to each other, might be you immediately recognize. This is a famous pattern, come on, you need to recognize it immediately. Two numbers added, the same two numbers subtracted, and I want to multiply them. Two numbers added, the same two numbers subtracted. What is this pattern called? Conjugate pattern. So the answer is x squared minus y squared. So I want you to use your knowledge. This is important. So this is the same conjugate pattern. So the answer is again simple. The first one to the 2 is 9 minus this one, as Rocco said, is 53. And then divided by 4. So it means that if you are patient and multiply term by term and simplify, at the end of the day, you will get 9 minus 53. And then 9 minus 53 is how much? Is minus 44 divided by 4. And then if I do it, it becomes minus 11. So I was able to answer this question. I gave you an equation, and I asked you what is the sum of the roots and what is the product of the roots. The sum of the roots is 3, and this one is minus 11. And then if you look a little bit closely, this number and this number are already somehow here. A little bit different for 3. Here 3 appears with negative sign, but minus 11 is exactly the same. So this is not a coincidence, okay? So I want to talk about this and how to find the general formula for that, okay? So this, of course, if I give you this and I ask you to find this, that's a complete acceptable answer from your side. But I want to tell you a little bit more. This is one problem in the book. The book has talked about the PQ version of this question, but let me use the ABC version, which is more general, because I don't need to have the x squared coefficient equal to 1. So let me tell you what is the question. The question is this. Let x1 and x2 be the roots of the equation ax squared plus b of bx plus c equals to 0. Then, this is I want you to show. Then, I would write show. You want to show this. x1 plus x2, you really don't need to go through this process. The answer to this is negative. You just divide b by a. That's it. As simple as that. And then if I ask you what is the product x1 times x2, you don't need to go through this process. You can just divide c by a. So these formulas in the book, they have used the PQ version. So a is 1, so it is minus b and c. But this is the most general form. Okay. I want you to have this in mind if you are interested in solving harder math problems. It's always good to know about this. Okay. So let me solve this problem in the book. How should I solve the problem? Exactly like this. But here I was dealing with numbers. Here I have to use algebra because I do not have numbers involved. I have letters involved, variables involved. Yes? But the method is exactly the same. So do you remember the roots? The roots are this. x1, so do you remember the formula? It's minus b, ABC formula, square root of delta divided by 2a. So one of them I can call x1, the other one I can call x2, because they are symmetric. It doesn't matter if I interchange them, the answer is the same. So it doesn't matter which one I call x1 and which one I call x2. So let me here, I chose the positive one, so let me stick to that way. So I will take this one to be the positive, the x1 root, and then let me choose the other one to be the x2 root. Okay, the first question is very simple. I want to add them. So it means that I have to add these two, but algebraically, not numerically. So it becomes minus b plus square root of delta divided by 2a plus minus b minus the square root of delta divided by 2a. So this pen, it was new this morning, so it's screaming actually, how much are you using me? But anyway, so yeah, I hope that you can see because I don't have any extra pen with me except the blue one. So here, 2a and 2a are the common denominator. But you see, I am going to add this to this. Minus b added to minus b becomes minus 2b, yes? But I don't care about what is this guy. What I see is that this is the same guy here and there, but one of them is positive, the other one is negative. So when I add them, it's canceled out, yes? It's nothing, it's canceled out. And then minus 2 and 2 can be simplified. Why? Because they appear as a product. So these are factors. They can be moved out. So this 2 and that 2 are canceled. So b and a are left, and a minus sign is left. So that's the minus sign. And that's exactly what I claimed here. I added these two. So this is not a coincidence. So if I ask you here this question, if you knew this formula before this, so you would say that a in this problem is 1, b in this problem is minus 3, c in this problem is minus 11, and then the sum of these two numbers is minus b, which is minus 3 divided by a, which is 1. Minus, this, it becomes 3, and that is exactly the same number that we got after the calculation. And now let me do the harder part. Let me multiply them. So here I multiply these two, but the methodology is actually exactly the same. The strategy is the same. Okay, so what happens in the denominator? 2a times 2a becomes 4a squared. And then, do you think that, again, this product is a conjugate pattern? Don't get confused. You see, minus b is repeating itself here and there. The square root of delta appears here and there, but once with positive sign, once with negative sign. So this means that's also a conjugate pattern. So if I want to answer that, it becomes the first one to the 2 plus minus, always minus, the square root of delta to the 2. Then I need to be patient and simplify this a little bit algebraically. Okay, minus b to the power of 2 is just simply b to the 2. But the square root of delta is squared again, it becomes just delta, okay? But what is delta? We know the formula for delta. It is minus. Delta is b squared minus 4ac. Be careful about putting this pair of brackets because this negative sign is for the whole delta. And then you divide it by 4a squared. And then I multiply this negative sign inside. This is not only for the first one, but it will also affect the last one. So this becomes b squared minus b squared, but positive 4ac. And then I have divided it by 4a squared. But minus b squared and b squared are canceled. So what is left for me is 4ac in the numerator and 4a squared in the denominator. But it is simply you can immediately see that all of these are factors. They appear as a product. So 4 and 4 are factors, common factors. They can be canceled out. One of these a's and one of these a's also cancel out. So what is left in the numerator is c. What is left in the denominator is a. So that is actually, I think, a level 3 problem in the book, but considering a is equal to 1. So from now on, if I were you, if you're interested in mathematics, I will put these things in my memory as well. So the sum of two roots is minus the coefficient of x divided by the coefficient of x squared, and the product of the roots is the constant term divided by the coefficient of the quadratic term. I know that I talked a lot today, but let me talk a little bit more, okay? So this problem that I am just writing now here might be even a little bit higher than A-level question. So this is somehow optional if you are interested, okay? So this is the final example. Let me see that if it works or not. So example. So let x1 and x2, so let me write optional. Let x1 and x2 be the roots of this equation, for example, x squared minus 7x minus 8. No, minus 8, this is simple. So minus 10 equals to 0. Determine the exact value of these expressions. For example, let me write one for you. x1 to the 2 plus x2 to the 2 and 3x1 to the 2 multiplied by x2 plus 3x1 multiplied by x2 to the 2. And this seems harder, but I think the second one is simpler. I want to hear a little bit from you, okay? So, of course, one way, I would say one naive way, is to solve this equation. Then, when you have them in principle, that's not a hard problem. When I found the answers, if I have computer available, I can put those numbers here and find the answer. Okay, but assume that you don't have any computer available, and then you want to do it more efficiently than doing this, because then for us it becomes hard. Because if I am right, this 1 to power 2 is 49, and then that is, so 89, yes, square root of 89 is not a complete square, so you have to deal with the square numbers, which is a hard subject. But can you tell me, how do you think about these two problems? Okay. Instead of asking this question, if I ask you this question, can you answer it for me? And if I ask you this one, can you answer this one? This is exactly what is on the board right now. If I give you this and I ask you these two question marks, both of them with what you see on the board is relatively very simple actually. What is the answer to the first question mark? Okay, can you tell me what are A and B and C? A is 1, B is -7, C is -10. If I ask you this, you can immediately answer that. x1 plus x2. Look at here. It's minus B over A. So it becomes minus B minus 7 over A, which is 1. Okay, so if you don't trust me, go and solve this and add the roots. You will see that you will definitely get 7. And then x1 times x2, according to the formula on the board, it's C over A. So C is minus 10 over A is 1, so it's minus 10. So these question marks are simple by what you see on the board. But what do you think about this and that? Let me start from here. I want to wait for you. My question mark is this. Does something come to your mind? What can I do here?
You just replace x1 and x2 with the solution, and then you can...
Okay, that is the naive way of doing that. Yes? The whole point of what I brought up is not to do that. By the way, I am too lazy to do that. If you solve this, and then you will immediately agree that the solutions are not nice, they involve square roots, and the question asks you about the exact value, you are not allowed to approximate, so you have to work with exact values in the form of square roots, and then 3 times that number with involving a square root, and then raise it to power 2, and then multiply it by that. Of course, I recommend you to do it at home like this, to understand what's the benefit of this way of solving that I want to present now. But another method, any other way, it's always possible to find the answers and put in this. The problem is efficiency of calculation. Here I am talking about efficiency of calculation. Any other method? So still you have a little bit of problems probably. I don't know, whenever I see this, immediately something comes to my mind. Do you see the same thing? What can I do for this if I want to do something? Say something. No, divide by 3 is not correct. Because I told you that I am not allowed to change. There is no equality. Of course, if I divide, yes, I have to divide the question mark by 3 as well. But what is question mark? I don't know. So it means that I am not allowed to divide. But somehow you are close, but not divide. What should I do? Okay, let me ask you. I want you to understand what are your weaknesses. If I give you this question, even I think in Math 1C, I could ask you this question. I don't want to use the word, but if I wrote something like that, can you write something in front of it? Because if I use the word, immediately you realize what I want to say. Can I write something in front of it which is equal to this one? Of course, I cannot add these two because they are not similar. Okay. But is there another expression that I can put in front so that the equality is guaranteed? No? Now I use the word factorize. So you need to understand, why didn't you answer me? Factorization, I'm waiting for you. Factorize this. How do you factorize it? We had it in Math 1C. I repeated the lesson in Math 2C as well. I'm waiting for you. Factorize it. Not just 3. Fully factorize. What are the common terms? 3 is one of the common terms. 1x and 1y. Yes. Are you studying, or coronavirus has affected your brain as well? Okay. X plus y. You have to study, by the way. Math 2C is a little bit harder than Math 1C. Yes? So now, do you agree with me that this is correct? Yes or no? I take it as a yes. Okay, but tell me something here. What can I do here? I'm waiting.
You factorize out x and 1 x1 and 1 x2.
And 1, 3, yes? So what is left here now? It's x1 plus x2.
1 x1 and 1 x2.
Exactly. But the problem is solved, don't you think so? Because what is this part? It's minus 10. What is this part? It's 7. Yes? So this becomes simply minus 210. As simple as that. But if I really want you to be ambitious and try to solve this not using this method. Go and, I don't know, find the answers, put them here. This will also teach you a lot of things, because you need to improve your calculational skills, okay? Computational skills. So if you do this, then you will see that probably it will take a little bit more than half a page to calculate this directly. But if you are smart enough to see that I can factorize that, and then even though I don't know x1 and x2 individually, but who cares? Because I know the sum, even though I don't know them, I know the product, and what I need to solve this problem is just the product and the sum, without knowing them individually. Who cares about individual values for x1 and x2? The plan, the design of the problem was in a way that if you were smart enough to see that I can write it in this way, what matters is the product itself and the sum. And the product and the sum are super simple, of course, if you know this theorem, okay, which is of course in front of your eyes. You will not be given these formulas in the formula sheet, and I will not give you these sort of questions in the exam. This is why I have written optional. But it doesn't necessarily mean that your brain is not at that level to solve this problem simply. I want you to learn, because that's the fun part of mathematics. It's just giving you a structured rules to following one after the other is not fun. Okay, so I will end the lesson right now, and then I will keep this one for you. Okay, if you are interested. Next time I will start solving this, even though it's optional, but immediately I will continue to the lesson. Okay, so I know that I talked a very long time here, but it might be I will give you a little bit more time next time to do your own practice. Okay, so if you don't have any question, I will end this stream. Live stream, then we are still in Zoom. If you have any questions, we can talk, and then otherwise we can leave the meeting. Okay, thank you for listening. We go back to Zoom now.